So a very common project or assignment you might get as a computer science student is checking if the number is prime or not. And that is what we're going to be doing today in this Python video. So it's going to work by basically if the number is less than or equal to 1, then it's going to return false because numbers that are less than or equal to 1 are not considered prime. And it will also loop through potential divisors from 2 to the square root of the number, and that is because if a number has a factor larger than its square root, it must always have a smaller factor. For example, if you have 16 and the factors are 2 times 8, you could say, and 4 times 4. So that's one quick example. Another thing we want to check is if the number is divisible by any of these values, which means that if you divide it by a value, it will give you 0, which means there's no remainder, then it will return false, because if it is divisible by something other than itself and 1, then it is not prime. And if there are no divisors found, then it will be a prime number, and it will return true. So this will all make sense with an example. So let's run through a quick little programming session. So to get started, as always, we're going to need to define the function, and we're going to call that isPrime. So we're going to check if it's prime or not, and we're going to have one argument, which is the number. Okay, so if the number is less than or equal to 1, what do we want to do? We want to return false, which means it's not prime. Now, we want to write a for loop to iterate through the range. So let's backtrack a little bit. Right now, it says if the number is less than or equal to 1, it's going to return false, because like I said, anything less than or equal to 1 is not considered prime. And then we have a little for loop here, which is going to range from 2 to the square root of the number plus 1. And if there are no divisors, if there's no remainder, it's going to return false, which means it's not prime. If there is a remainder, then it will return true. And this is how you find the square root of the number, and you need to add 1 because it will always be 1 less, so you need to add 1. So let's continue. So this is just to check if it's prime or not, or just to check if the number is prime or not. And then we're gonna have another function, and we're gonna call it prime underscore checker. There is a way you can put these two together, but I'm just, for the sake of simplicity, I'm just making them separate. So let's do the next function. So num, which is a variable short for number, it's going to be int input. We're going to be typecasting the string to integer, and we're going to say enter a number to check if it's prime. Okay, moving on. We will check if it's prime now. So we're going to say if is prime, and then we're going to pass in the number as the num as a argument. So if it's prime, we're going to print f, and we're going to say that the number that we inputted or entered is prime. So is a prime number. And if it's not, then it's not. So we're going to say else print f, and then we're going to do the same thing. Num is not a prime number. And then we're going to call the function prime checker. Okay, that's great. I don't know why I have is here. I was probably talking when I typed it, but let's try it and see if it works. So enter a number to check if it's primed. Let's say 5. 5 is a prime number. Okay, let's try again. Let's say 9. 9 is not prime, so it's not prime. Okay, let's say 53. It's a prime number. Okay, let's say 99. Prime, not a prime number. Okay, let's say 1, not a prime number. Let's say 2, it's a prime number. Okay, so you can see clearly that it works perfectly. And that's pretty much it for this video. I hope you guys enjoyed or learned something new. If you did, please like and subscribe, and I'll see you guys in the next one.